Hello everyone, in this tutorial we are going to provide a solution to this interesting trigonometric equation 4 raised to the power of sine squared theta plus 4 raised to the power of cosine squared theta equal to 5, and we are looking for that angle theta that can satisfy the equation. Don't forget to like, comment and subscribe. Let's get started. I would like to either transform sine squared theta in terms of cosine squared theta or cosine squared theta in terms of sine squared theta. And how can we do that? Remember this identity, sine squared theta plus cosine squared theta equal to 1. So if I like, I can say that cosine squared theta is equal to 1 minus sine squared theta. So instead of cosine squared theta, we can now replace it with 1 minus sine squared theta. So we have 4 raised to the power of sine squared theta plus 4 raised to the power of 1 minus sine squared theta instead of cosine squared theta, and this remains equal to 5. Remember this law of indices, we stated that a raised to the power of b plus c is equal to a raised to the power of b times a raised to the power of c. We can apply the same law here because we have 1 and negative sine squared theta. So we have 4 raised to the power of sine squared theta plus 4 raised to the power of 1 times 4 raised to the power of negative sine squared theta equal to 5. And remember, since this is negative, we can write it as 1 over the whole of this. And if we like, we can leave it like this. Let's perform a substitution. Let y be equal to 4 raised to the power of sine squared theta. So wherever we have 4 raised to the power of sine squared theta, we're going to replace it with y. So we have y here, right? Plus 4 raised to the power of 1 is 4. Then the whole of this will give us y to the negative 1. Why? Because you can see we have a negative sign here. So it will be y to the negative 1. And this is equal to 5. And remember that y to the negative 1 is the same thing as 1 over y. So we can multiply every single term by y. Y times y will give us y squared plus y to the negative 1 times y will give us 1 times 4 is 4. This is equal to 5y. So we have just multiplied every single term by y. So let's bring this one inside. We have y minus 5y plus 4 equals 0. This is now a quadratic equation that can be factorized. Two numbers we can multiply together to get 4. The moment we add them together, we get negative 5. I think the numbers are negative 1, negative 4. Yes, so let's continue the other side. So we have y minus 4, y minus 1. These are the two numbers you can multiply to get positive 4, and the moment you add them together, you get negative 5, which implies that y is either equal to 4 or y equal to 1 by taking the corresponding constants to the other side. But remember that y is what? 4 raised to the power of sine squared theta. So it means that 4 raised to the power of sine squared theta is either equal to 4 or 4 raised to the power of sine squared theta is equal to 1. All right, let's start with this one. Having the same basis, we can equate the exponents. So remember, this is 4 to the power of 1 naturally, which means that sine squared theta is equal to 1. And sine theta, by taking the square root of both sides, is either positive 1 or negative 1. Or negative 1. So the question is, sine of which angle is 1 and sine of which angle is negative 1? I'm coming back to this. Let me solve this one. You know that this is the same thing as what? 4 to the power of 0. So this is 4 to the sine squared theta equal to 4 to the power of 0, so that we have common basis, which implies that sine of square theta is equal to 0 take square root of both sides, you have sine theta equals 0. So we have 3 equations to solve. 1, 2, 3. I'm going to solve them on a unit cycle. Let me show you. So here is our unit cycle, and we are going to use it to solve these 3 equations, 1, 2, and 3. So let's start with the first one. Sine of what angle is 1? Remember, sine depends on y coordinate. So we are looking for y coordinate where we have 1. You see, we have 1 here. So at 90 degrees, we have a solution. 90 degrees. And if you go around, you come back to that point, you have another coterminal angle. But for now, just leave it as 90. What about this one? Where do we have -1? We have -1 at this point, which is at 270. So sine of 270 is -1. And if you keep on going round, you're going to get other coterminal angles. What about sine theta equal to 0? Sine of 0 degrees is 0. Sine of 180 is also 0. So we have a solution at 0, and we have another solution at 180 degrees. So you can see that we have solutions on all of these 4 points. 1, 2, 3, 4. So how can we write them all at once? Because from here to here is 90, from here to here is 90, from here to here is 90. It means that if we should take 0 degrees and add 90 degrees, it will take us to this. Add another 90, it will take us to this. Add another 90, keep on adding 90, 90, 90. So instead, we can just write it as 90 degrees, K or N or whatever, multiples of 90 degrees. So this angle we are looking for is nothing but multiples of 90 degrees, for which this K is an integer. As simple as that. So, you know 0 and 360 degrees have the same ratios. So if we consider 90 degrees as our first solution, add 90, it would give us this. Add 90, it will give us this. Add another 90, it will give us this. Keep on adding 90s. So this is the general solution for all of these 3 equations that can satisfy this. If you like, you can take 90 degrees, plug it here, simplify and see whether you're going to get 5. When K is 0, it satisfies. It means that 0 will satisfy as well. So 90 will also satisfy. 180, 270, 360, keep on going round and round and round. Bye-bye.